All right, so for this first one, we've got a wavelength, and we need a frequency, and we need a certain amount of energy. How much energy it's got. So, so I got 5.5 times 10 to the 14th, 1 over seconds for my frequency. And then for energy, I need 6.626 times 10 to the negative 34th joules times seconds. And then I've got 3 times 10 to the 8 meters per second. And then I've got 5.5 times 10 to the 14, 10 to negative 7th meters. And then I can cancel out the seconds, and I can cancel out the meters, and that just leaves me with joules. So this is 3.6 times 10 to the negative 19th joules. Are we okay with how I did that? Nobody wants to say anything about that?
I was just trying to figure out which map applies to which problem.
Does it matter?
Well, this one, there's two different ones. It's two different sections you need to go to.
No. One step each time. So I'm just looking for frequency, right? And so what I need to know is the unit for frequency, which is 1 over seconds. So I just throw together the speed of light and the wavelength together so that I cancel out meters and leaves seconds in the denominator by itself. So that's how I got that. And then the next one, I needed energy, so I need a joule number. So I'm going to need to put that Planck's constant up in the top and cancel the seconds out. The only way to cancel the seconds out is with the speed of light. When the speed of light cancels out the seconds, then it left a meter unit, so then I use my wavelength again to cancel out that meter. Tony?
So my estimates are like off by quite a bit.
Are you typing that into the calculator?
Yeah.
You're not typing that into the calculator. What do you mean you don't have that? Of course you do. Yeah. If it has a caret, then you do. This needs to be used. So if I have, say, in this problem 5.5, and I type it into my calculator like this, it sees 5.5 and it sees 10 to the negative 7th as two separate entities. And then if the order of operations isn't done correctly with parentheses, you'll get the wrong exponent. But if I put 5.5e negative 7, it sees that as a single number. So you got to use that e. What calculator do you have? You're using Google? Oh, I don't know what Google Calculator does, but I'm sure that probably works. It's probably also got to have an E on it. That would be my guess. Really, nobody has any problems with what I did up here? Could have been shorter? Where?
You just have the answer, but
Don't do that. I was just waiting for somebody. I had to like push you into the hole instead of you walking into it. But why should you not use your answer to calculate the next answer?
Because you might be wrong in the first answer.
Okay, one, you might be wrong in the first answer, but that's not what I'm super worried about. What I'm really worried about is you gave me the correct answer with the correct number of sig figs, which probably forced you to do what? Gave up sig figs and possibly round. And now you put that rounded number into the next problem and you get an answer that seems reasonable and it's off by a decimal place, or it's off by a number, say in the first or second decimal place. So I guarantee when you take a standardized exam, they have to give you the answer, right? So since they gave you the answer, they have to trick you into thinking the answer you have is wrong or the answer you have is right or whatever. All right. So the first answer, A, will be whatever it is, 6.626 times 5.5 times 10 to the minus 14th. And then D is going to be the way I did it there. And so my guess is in the problem you would be looking at, hypothetically, it would be off. Instead of it being 3.6, it'd be 3.5 or something like that. And it would be seemingly insignificant, but it's about, if you can get the answer from given information, do it. If you can only get the answer by using calculated data, calculated information, use that. But if you can get, so that second answer there about the energy, I got that answer by using what they gave me in the problem, not by using the previously calculated answer. So do it this way instead of the first way. Or instead of the way Walter wants to do it. When he's pushed. Yeah. Frequency of this photon, what's its wavelength? Where is it on the spectrum? Okay, so I need a wavelength. So I'm going to start with 3 times 10 to the 8th meters per second. And I'm doing that because meters is the length. And then I can write 4.5 times 10 to the 14th with seconds in the numerator because it's in the denominator and the value. So we've got 3E8 divided by 4.5E14, and I get 6.6, or 2 sig figs. I get 6.7 times 10 to the negative 7th meters. And then the energy on that. So it's 6.626 times 10 to the negative 34th joules times seconds. And if I put 4.5 times 10 to the 14th 1 over seconds here, then my seconds units will cancel out. So 6.626 E negative 34 times 4.5 E14. I get 3.0 times 10 to the negative 19th joules. Where does it fall on the spectrum? Well, if I take this number and I make this, what's that going to be? 6700 times 10 to the negative 9th meters. And so I'm putting it in as 10 to the negative 9th because that's nanometers. And so I just happen to know that the nanometers for visible light are between 400 and 700. So what I have here is something that's, close to 7,000. So that's longer. So where am I probably falling? Infrared. Red's the longest. This is longer than red. So this is going to drop into the infrared zone. Somebody else figure out another way? You look at the chart? All right, that's fine. Go ahead.
chart or something like that.
No. No,
Not gonna ask this question.
correct. I could ask you relative, but I'm not going to be specific. I'm not going to ask you this specific. I'd have to give you the thing, and I don't really care. I just want you to know what's the most important thing about that whole spectrum of different types of radiation. No, the line that goes between violet and ultraviolet. Once I've crossed that line and gotten wavelengths that are smaller than that or frequencies that are higher than that, now all of a sudden the energy of that radiation, of that light, can break bonds and cause cellular damage to the point where you can have DNA mutations, so cancer. Yeah.
Why don't you just use the equations instead of doing the random? Does anyone think about canceling?
I don't think about anything.
Well, you are, because you're wanting the seconds on top, blah, blah, blah. Instead, you can just I just need this variable here, and then plug it in.
Then I have to remember our equation.
I guess that's an easy equation.
I never use them though. So what happens that if you're doing this for a job or a test or something, and there is no equation on the back page of the whatever?
Google.
You work in a basement and the internet's down. No phone service, sorry. Atomic line spectra. You could have drawn this a couple of different ways. I'm going to draw it like this. That looks terrible. I'm going to draw it like this. Radiation comes in and excites the electron. The electron gets the exact right amount of energy to jump up to a higher energy level. And once it's up there, it needs to fall back down to ground state where it was. And as it's falling back down, every time it drops down an energy level, getting closer to where it was, it releases energy. And so this is light. These both are light. I keep trying to draw a wavelength for some reason. So if I'm looking at the visible spectrum, there's a line and there's a line, and that corresponds to that one, and that one corresponds to that one. And depending on all the other electron drops, they give you different lines. So remember when we talked about sodium last week? There were just 2 yellow lines, and that was all that was coming off that was in the visible spectrum. So anything that's got sodium in it looks very yellow. The yellow is so powerful it overshadows the rest of the colors. So since every element has a different number of electrons, every element has its own specific atomic line spectra. The other thing you could have drawn is you could have drawn the energy level diagrams and then talked about electrons bouncing up and dropping back down and then the light coming off of there. Doesn't really matter. Okay, so light is a wave for what reason? And it's particle Y. Packets, photons. Photons leads us to what? Photoelectric. What's the easiest way to describe refraction to just a regular old person who's not studying chemistry? Okay, anything easier? No, that's constructive and destructive interference. You just say rainbow, right? What's happening there? The light's hitting water, and as it goes through the water, each of the different types of light, each of the different colors in that case, they all have different wavelengths, and so they all bend at a different angle, which is why it spreads the light out. It used to be all chunked together in one bundle, and then when it hit the rain droplets, it split apart through refraction and shows you each of them. Would that work with other types of radiation? Could you shine a bunch of different UV through? Because there's a whole bunch of different types of UV light. Do you think it would refract them? Yeah, it doesn't care. It doesn't care if I'm shooting different types of X-rays through it, it still refracts.